Right, girls, we're going to have a look at thermochemistry there now, which is the calculation part of the fuels question, question 6. I'm going to have a look at 2004 for a start. You can see there that the equation that they've given us is methane and oxygen giving carbon dioxide and water, and they've given us a delta H of minus 890.4 as well, kilojoules per mole. In the question, part 6, part B, they've also said that the standard heats of formation of carbon dioxide and water are minus 394 and minus 286 kilojoules per mole, respectively. So what that means is if there are heats of formation, the first one is of carbon dioxide, CO2, and the delta H is minus 394. And for a heat of formation, you just have to figure out how to make it. You need carbon and oxygen to get carbon dioxide. Quite a straightforward one there for the first one. The second one then is water, H2O, and the delta H that they've given us is minus 286. To make water, you need H2 and you need O2. You need to balance this, half O2, to get us 1 mole or 1 molecule of the water. Minus 286 is the number that they've given us. So they've given us these two and this one. We've got 3 different equations, and the question that they ask us is calculate the heat of formation of methane. So if you were to find the heat of formation of methane, CH4 is methane. You're looking for delta H of this reaction. For the CH4, well, you're going to need carbon and you're going to need hydrogen, 2 hydrogen. So this is the reaction that you're looking for. You've got these 3 different equations. We're going to label them A, B, and C, and we're going to put together these 3 parts to find the delta H. So if we're looking at C, we're going to need equation B. That's the only one that has C carbon in it. So I'm going to write down the equation B. C plus O2 gives us CO2, and the delta H is equal to minus 394. So that's the carbon ticked off. The next one is hydrogen, H2. We can see that in equation C. We need 2 of them though. So we're going to take equation C and we're going to multiply it by 2, which will give us 2 H2s and 2 halves, which gives us an O2. And then that will give us 2 waters, 2 H2Os, and we'll have to double the delta H there now as well. So 286 multiplied by 2 should be minus 572, and that ticks off the H2. The last part that we need is the CH4, the methane. We'll get that from equation A. It's over here on the left hand side, so we need it on the right hand side, so we're going to have to flip A around. So the way I like to write it is A multiplied by minus 1. So I'm going to write down CO2 plus 2H2O gives us CH4 and 2O2. So it's A backwards. For the delta H, we're going to have to inverse it as well, or invert it, 890.4, which means that we're going to have the opposite sign on it. Okay, so that is where we're at. If we write everything down, we've got carbon and oxygen and another oxygen, so that's 2 oxygen. We're going to have 2 H2 and we're going to have 2 CO2. We're going to have 2 H2O. That's the left hand side. Then we're going to have CO2 and 2 H2O and CH4 and 2O2 from there. And then we're going to see what's cancelling. This cancels with this, so we can cancel them out. The 2H2O will cancel with the 2H2O. And wrote down 2 CO2. It was just the 1 CO2 there. Cancels with the 1 CO2 there. They cancel. What you should get is you should get exactly what you're looking for. So we've got C plus 2H2 gives us CH4. And once we add up all these numbers, which will be 890.4 minus 572 minus 394, we get delta H is equal to minus 75.6 kilojoules per mole. And that is the answer there for 12 marks, the heat of formation of methane.